All right. So now we'll move on to. Sorry about that. Okay. So without further ado, from current slide. Okay. Okay. So the structure of the liver, right, is mostly on the right side. It's upper right quadrant. It has amazing regenerative abilities due to mitosis of hepatocytes. The liver is the only organ where you can donate a portion of it and have it grow back within months. In fact, you can donate 70% of your liver and it'll grow back within a couple of months. Okay, and they've known this since actually the ancient Greeks. Okay. 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 So they compose of hepatocytes that form hepatic plates, separated by capillaries called sinusoid capillaries, because they go back and forth. And these capillaries have not just fenestrations, but huge holes. Okay. 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 This is the anatomy portion. Okay. The hepatic portal system, you should know what that is. Okay. Okay. So. Okay. Bile production. Bile is made of bile pigment, which is bilirubin, which is derived from heme actually, and then this stuff right here. The purpose of bilirubin and bile ultimately is to make things both fat soluble and water soluble, which makes the bile emulsifier. Okay. Okay. So the bilirubin is also why your poop is brown, in case you want to know that. Okay. So bile salts. Okay, so this is bile salts. Okay, and so you have a polar and non-polar region that allows the polar and non-polar things to mix. Okay. All right, the liver can remove hormones, drugs, substances in three ways. Is one excreted in bile, that is not helped by Kupffer cells, okay, and then chemically altered by hepatocytes. One of the most important things is it gets rid of ammonia, okay? When we eat things that have a lot of amino acids, one of the things we produce when we cleave off the nitrogenous group, we usually cleave it off in terms of ammonia. Okay, ammonia is toxic, and so the liver quickly converts two ammonia atoms into or molecules into urea. Okay. Okay. Porphyrins into bilirubin and purines into uric acid. Okay, that's another important thing. Okay, the urea and uric acid is actually returned to the blood to be filtered by the kidneys. Okay. The liver can also do some really cool things. It stores glycogen for one. It stores about 2,000 calories of glycogen in the liver. Okay, and it can also make sugar. They can make glucose from amino acids and convert fatty acids into ketones, which your body can process for energy in your brain, basically. And that's gluconeogenesis and ketogenesis. Okay, it produces clotting factors, globulins, albumin. All right. Cirrhosis is when the liver is amazingly good at regenerating itself, but sometimes it doesn't work, and that's when cirrhosis happens. Okay. Most common causes of cirrhosis are hepatitis B and C. Okay, hepatitis. Okay, and non-alcoholic steatohepatitis, which is fatty liver. Okay, if you have cirrhosis, 65% chance of surviving in 3 years, but there's no chance if you don't stop drinking because your liver is fatally important. Okay. Okay, so that's pretty straightforward. Okay. Alcoholic fatty liver disease occurs in people who are moderate to heavy drinkers. Okay. All right. Alcohol oxidation occurs in the liver where it's metabolized acetaldehyde, which is then converted to acetyl-CoA, which is then, shunted into fatty acid pathways. Okay. So the symptoms of alcohol or liver failure is jaundice. Okay, jaundice is a yellowing of the skin and even the sclera of the eyes. Okay, caused by high levels of bilirubin. Okay. Okay. Pre-hepatic jaundice refers to increase in free bilirubin due to increased hemolysis of red blood cells, which produces more heme groups for conversion to bilirubin. You see this usually in newborns, okay? Newborns, especially of Asian descent, tend to get pre-hepatic jaundice, okay? So hepatic jaundice is damage to the liver, okay? Post-hepatic jaundice is or obstructive jaundice is a blockage of the drainage of bile, blocking of the bile ducts, okay? Gallbladder, there's a gallbladder, the gallbladder is just basically a little sac that secretes bile, okay? Okay. Gallstones are produced when the liver secretes enough cholesterol to create a supersaturated solution, and so you get crystallized. And then one of the things that happens in the gallbladder is whatever's in the gallbladder is more concentrated. So what happens is then you get crystallization of cholesterol. Okay. Okay. Gallstones. Okay. All right. The pancreas. The pancreas has both exocrine and endocrine functions. The endocrine functions are located on the islets of Langerhans, and they make insulin using beta cells and glucagon using alpha cells. Okay, the exocrine function, which we're covering today, they make pancreatic juice. Pancreatic juice has two components. Okay, One is the inactive enzymes, also known as zymogens. Okay, zymo, enzyme, generating. These are inactive enzymes that will go into the small intestine and they'll get activated in the small intestine and work in the small intestine. Okay, because again, if you turn on these enzymes too early, they'll digest away the pancreas, and that is something that happens actually in pancreatic cancer. Okay. The other component that's important in the pancreatic juice is the bicarbonate. The stomach has a pH of 2, so things that are leaving the stomach have a pH of 2. The small intestine needs a pH of 7, and so to get there, you need to add a lot of base. The base comes from the bicarbonate secreted by the pancreas. Okay. Okay. So here are all the enzymes secreted. Okay. Notice all of them in ASE except for trypsin and chymotrypsin. Trypsin and chymotrypsin are literally one of the first enzymes we discovered, and this was before the typical nomenclature of and adding an ASE. In fact, the sin at the end is a digestive enzyme identification. Okay, really old version of it. Okay. Okay. So bicarbonate is secreted by the liver. Okay. Okay. The pancreatic enzymes both are inactive. This is spelled wrong. This is zymogens, not genes. Okay. So enterokinase activates trypsinogen to trypsin. Trypsin then cleaves chymotrypsin, and then they do other things. Okay. Okay. So this is the brush border. Okay. This enzyme cleaves trypsinogen into trypsin. Trypsin cuts other inactive enzymes like chymotrypsin or chymotrypsinogen to chymotrypsin. Okay. Okay. Hepatitis, inflammation of the pancreas. Okay, so in pancreatitis, pancreatic enzymes can be abnormally activated. If you abnormally activate enzymes in the pancreas, you'll digest away the pancreas. Okay. All right. Regulation. So, okay. So, the sight, smell, thought of food can prime the digestive tract for digestion. That's why you hear the grumbling of the stomach. You hear the not hear the salivary glands, but saliva. Okay. So here are the enzymes that are involved. Okay. Okay. So ACL pepsidogen occurs when proteins enter the stomach, that's therefore digesting proteins. Okay. Okay, so celiac phase controlled by the celiac. So celiac is celiac. Cephalic is brain. Okay, so brain via vagus nerve. Gastric phase, arrival of food in the stomach. Okay, and that is a positive feedback loop. Okay. Also coupled to that is a negative feedback loop where too much HCl causes somatostatin to be released. Somatostatin inhibits gastrin and sends signals to that you're full. Okay. Okay. Okay, and then the intestinal phase. Okay, the major one of these is actually CCK. CCK, or cholecystokinin, is secreted by the duodenum in response to chyme entering in, and it causes bile release and release from the pancreas. Okay. Okay. So this CK is produced in response to the process presence of partial digested proteins and fats in the chyme. So again, this is released. So trypsin, lipase, amylase is secreted by causing CCK. Okay. Okay. So secretion of bile is also by CCK. Okay. All right. Okay. So digestion of carbohydrates starts in the mouth. Okay, of salivary amylase. Like if you take a cracker, put it in your mouth, and you just leave it there, it'll start to taste sweet after a couple of minutes because you're breaking down the starch, the polysaccharides, into disaccharides and stuff. Okay. There's no digestion of starch in the stomach, and then you have continuous intestines, pancreatic amylase, okay, and then the brush border finishes breaking down into individual sugars, okay, mainly glucose. Okay. Okay, and then you absorb them through GLUT transporters. Okay, digestion of proteins. We talked about pepsin already. Pepsin then cuts it into small chains. The small chains get cut with trypsin, chymotrypsin, elastase, carboxypeptidase, and the brush border enzymes, aminopeptidase. And finally, what you're left over is really, really, really short chains of 1, 2, or 3 amino acids. Okay. Okay. The last one, digestion of fats. Fats is a little bit different. Okay. Fat digestion begins in the duodenum with bioemulsifies of fat and pancreatic enzyme lipase. Okay, it breaks it down into fatty acids and glycerol. Okay, imagine for a second what would happen if you didn't have pancreatic lipase. Lipase breaks down fat. So what would happen if your pancreas didn't break down fat? Well, it would continue through your digestive tract. Okay, and that is what um, the diet drug Ally. Okay, it inhibits pancreatic lipase. You can't inhibit it completely because that will kill you, but it cuts it down by about 25%. So you end up with more lipids coming out the rear end, for better or worse. Okay. Okay. The absorption of fats is a little bit different. They're transported through the lacteals. Okay. Okay. All right. So that ends this presentation. We'll pick it up in the next chapter.